Okay, I mentioned this actually, everything I'm about to say I mentioned before in the last video, but I just want to make sure I say it explicitly, and there's some nice pictures in your book and some ways they explain it very nicely, and I'm going to bring up a few extra terms and expound on it a little bit. But an ionic compound is important to realize. What makes an ionic compound, the reason we call it ionic, is it's made up of ions. So the components of an ionic compound, some people will say metal, non-metal, but I think it's better and more general to think of it as cation, anion. And remember, cation means positively charged ion, anion means negatively charged anion. Or negatively charged ion. Okay. Ionic compounds don't form molecules. So remember I said there are certain compounds that don't form molecules. Ionic compounds is what I was referring to. So there's omnidirectional, omni means all. So omnidirectional nature of electric charge means that it's not like bonds. Next chapter we'll talk about covalent bonds and molecules. And in there, when you have a bond between carbon and oxygen, the bond is very directional. It's focused between the two atoms. But if a bond, an ionic bond, the positive charge just attracts any negative charges in any direction around it. So what we get is we get this lattice, this three-dimensional structure alternating sodium ions and chloride ions. And why sodium is so much smaller than chloride is a little bit beyond what we're going to talk about in this class. So just, I guess, think of it this way. Sodium has had its last shell stripped away, so it's smaller. It has no third shell. So because we have this lattice, right, the formula isn't really a molecule. It's a representation of the smallest neutral unit, or the ratio in the lattice. So instead of calling it a molecular formula or a molecule, so whereas you have water, water is the formula, and if you have just an oxygen and two hydrogens, you call that a molecule. The analog for an ionic compound, for example, if you have sodium sulfide, right? A compound, or the unit that is one sulfide ion and two sodium ions, in other words, the unit represented in the formula is called the formula unit. So it's the smallest whole number repeating ratio of ions. So the formula in a molecular compound represents a molecule. The formula in an ionic compound represents the formula unit. They're going to function in most ways identically, but I just want you to be aware of the conceptual difference. There is a physical separation from one molecule to the next. There's no one formula unit in an ionic compound is bonded to the next formula unit, just like the formula unit is bonded within itself. Okay, important things about compounds versus molecules and how to identify one versus the other. So, I keep hammering on this, but people forget this a lot. Covalently bonded compounds have molecules as their basic units. Ionic substances have ions or formula units as their basic substances. Here's how to identify the difference. Covalent substances you can identify as being made up of all nonmetals. So if you see a formula, CO2, H2O, C6H12O6, right? All these are, so here, this formula has nothing but nonmetals in it. Carbon and oxygen are nonmetals. Hydrogen and oxygen are nonmetals. Carbon, hydrogen, and oxygen are all nonmetals. These are all covalent. OF2, nonmetals, right? So these are molecular. Ionic substances are made up of metals combined with nonmetals. There's going to be like an exception a little bit later, but metals combined with nonmetals. So, for example, sodium, which is a metal, fluoride, and aluminum oxide, and like that. And it's always going to start with the metal. The metal will be at the beginning. So I want you to just take a moment and tell me whether each of these substances here is made up of molecules, yes or no. So Na2O, that's a metal and a nonmetal, so that's ionic, so it is not made up of molecules. Water, H2O, yes, all nonmetals. CH3F, all nonmetals, yes, made up of molecules. FeSO4, iron is a metal, no. Calcium chloride, metal, no. Not molecules, so only these two are actually made up of molecules. So hopefully that makes some sense. That is all I have to say about the structure of ionic compounds, really.